first lesson is all about illustrating a random variable, whether discrete and continuous. For this lesson, you're expected to define random variable and illustrate random variables, whether discrete and continuous. So these are our objectives for this lesson. So before anything else, let's define first the terms that we will be using in learning this lesson. So first we have the word experiment. I know you're familiar with this word because this is used in your subject science. So in this subject, statistics and probability, experiment is defined as any movement that should be possible more than once under comparative conditions. So meaning, this is any activity that is possible, that can be done more than once, not just once. It can be done twice, thrice, or as many times as possible. Example is tossing a coin. In tossing a coin, you can do it not just once, you can do it twice, thrice, or as many times until you get tired. Another one is sample space. Sample space is the arrangement of every possible outcomes of an experiment. So when you do an experiment, what are the possible outcomes? Example, when you toss a coin, what are the possible outcomes that you will get? So we have, it's either head or tail. So observe that writing and in writing sample space, you will enclose it in braces, and they are separated. Every outcome is separated by a comma. So head is an outcome and tail is also an outcome. So when you write the possible outcomes, you can do it in any order. You can also write tail first, followed by head. So it's either head or tail, tail or head. So this is a sample space. So the next word is random, which means chosen, done without a particular plan or pattern. Example, drawing raffle tickets or names from a bowl. When you draw a raffle ticket, draw means it's not drawing like drawing a kite, drawing a flower. It's drawing means choosing or picking raffle tickets or choosing raffle tickets from, example, from a tambulo. Are you familiar with the tambulo? Or from a box, example. So when you draw raffle tickets, when you choose winners, we do not know who is the winner or what raffle ticket will appear. So when you choose a raffle ticket and we do not know who is or the winner or who will be the lucky winner, then that is random. Another example is drawing names from a bowl. So when there are names written on a piece of paper and put it in a bowl, and we choose name from a bowl, we choose a piece of paper from the bowl, we do not know what name will appear on that paper. We do not know what name will be chosen. So that is already random. So it is not random when there is a pattern. Example, when the when you choose names from above with colors, example, I will choose yellow, I will choose red. So that is not already random because it is planned or there is a pattern. So it is random when you do not know what will happen or what will appear. The next word is variable. It is a quantity that can have only one, or it can have any one of a set of values or a symbol that represents a quantity. So I am sure that you are familiar with the word variable because this was discussed during your junior high school days. So in this subject, it is a quantity that can have any one of a set of values or a symbol that represents such a quantity. So a variable, example, age, civil status, or it is it represent it is represented by capital letters, so X, Y, Z. So example, let's take for example age. So age can have not just one value, but it can have many values, a set of values. You can have age as 1, 2, 3, 4, 5, and so on. So there are many values that it has many values. Another one, civil status. So in civil status, a variable, it can have any one or set of values. Example, civil status is either single, married, or separated, or widow or widowed, example. Another one, we have here x. So take note, a variable is represented by capital letters. So any letter found in your alphabet. So mostly we use x. This is the common variable that is used in variables because x is well known as unknown. If you do not know the value, you can use x. So let's combine them together. We have random variable. So random variable, the value depends on the outcome of a random process. So it has a value. So when you do experiment and in a random process, random means you do not know. It is done, it is chosen without a plan, without a particular plan or pattern. So you do not know what will happen or what will occur, except you have sample spaces, you have possible outcomes. So it has a value, and that value is expressed in numerical. So in numbers, the value is expressed in numerical outcome. It is denoted with a capital letter. You can use any letter from the alphabet. And it's either discrete or continuous. So you will know what is discrete and what is continuous later on. Example, we have number of heads, number of tails, number of boys in the family. So number of heads is a random variable because this is an outcome from a random process. So take note, random process example for the number of heads is tossing a coin. So tossing a coin is a random process, and the random variable that we're trying to get the value is the number of heads. So its value is expressed in numbers, in numerical. And we can use any capital letters from the alphabet. Example, we will represent the number of heads as X. You can represent number of tails as Z. You can use any letter. So this is a random variable. So as previously defined, a random variable has two types. It's either it can be a discrete or continuous. So let's have discrete random variable. What is a discrete random variable? So this is a variable that can take on a finite number of distinct values. So you have there the word finite. So when we say finite, it is limited in nature. When we say limited in nature, you can count them. It is countable. So we also so while the continuous random variable is a variable that can take an interminably uncountable number of potential values, regularly measurable amounts. So since discrete is countable, this is the opposite, exactly the opposite of discrete, since this is uncountable. You can count them, you can count the values. The values of continuous random variable cannot be counted, but instead, it is measurable. It can be measured. So you will understand these two types of random variable as we go along with this lesson. So let's have an example. So let's have here an example. Example number one, tossing a coin. I know you're all familiar with this kind of activity because you do this when you are playing games or when you're bored, you toss coins. Okay? So example, toss your 1 peso coin 3 times and record in your notebook the results of the 3 tosses. In order to write the result easily, use letter H for the heads and the letter T for the tails. Example, you toss a coin first, toss coin, and it appeared to be a head. So you write letter H first. Then second time you toss a coin, example, it appeared to be a tail. So you write letter T. And the third time you toss a coin, it appeared as head. So you write letter H. So you have here the first outcome as H, T, AH. So this is the first outcome. So of course, we have here the sample space. Another one, if you continue, if you do it again and again, so since it is experiment, you can do it more than once. So it happened that when you toss a coin for the second time, 3 times, it happened that it appeared as head, head, tail. So this is just an example. Now, tanakang pagpabudlayan, this is the result. So, tossing a coin. So, we have here experiment, tossing a coin 3 times, and we have here the sample space, the arrangement of the possible outcomes from the experiment. So, you have noticed, observed how it is written. You have there the brace, and the possible outcomes separated by comma. Okay, so example. So here, in sample space, when you toss a coin 3 times, the possible outcomes that would appear might be we have 3 tails, 2 tails and 1 head, tail, head, tail, tail, 2 heads, head, tail, head, tail, and we have the last as 3 heads. So if you observe, we have how many possible outcomes do we have here when tossing a coin 3 times? So we have here 8 possible outcomes. So 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 possible outcomes. Nothing more, nothing less. Now, the problem here is determine the number of heads that appear. So you are concerned with the number of heads. Number of heads that appear when we toss a coin 3 times. So this is our problem. What here we have here a question. What is the random variable here? So of course, since we are concerned with the number of heads, apparently this is our random variable. And its value depends on the outcomes that we did from the experiment. Okay, let's proceed. Now, from our sample space, we'll list down the possible outcomes in a table, and it is placed here. So these are our possible outcomes from our sample space. And on the second column, we have here the random variable, which is the number of heads, and it is labeled as, it is represented by the capital letter X. So we have here the 8 possible outcomes. First, we have the 3 tails. So how do we get the value of the number of heads or our random variable? So we simply count the number of heads from each outcome. Example, from our first outcome, we have 3 tails. So how many heads are there in 3 tails? Of course, you cannot see any head there, so that is why the value is 0, since there is no head in our first outcome. On the second outcome, we have here how many heads are there in our second outcome. So we have 1 head, so that's why the value is 1. On the third outcome, we have 1 head, so that's why the value is 1. On the fourth outcome, we have 1 head. On the fifth outcome, we have 2 heads. And on the sixth outcome, we have 2 heads still. And on the seventh outcome, we have 2 heads. And on the last outcome, we have 3 heads. There are 3 heads on the last outcome. So these are the values of the number of heads which was determined from the possible outcomes. So these are our possible outcomes. Now, what we're going to do next is we're going to summarize the values of our random variable or the number of heads. So we have here in the first column our random variable, the number of heads represented by capital letter X. Now, as you have noticed, we only have 4 possible outcomes. That is why we only have here values such as 0, 1, 2, 3. Because from here, from our values here, you can only see values such as 0, 1, 2, and 3. So these are the possible outcomes. Now, on the next column, we have here the probability or the P of X. So, by the way, what is probability? Probability is also called as possibility. So, probability or the likeness or the possibility. So, probability is expressed in numerical also. What is the possibility that it would appear? Example, we have here the number of heads, 0. So what is the probability when you toss a coin 3 times, the number of there is no head that would appear, or 0. The number of heads is 0. Of course, we only have one um, we only have one outcome, that there is no head, and it is represented by 3 tails. So when you toss a coin and it happened to appear as 3 tails, then there is no head. So that is why the probability that the number of heads that would appear is 0 is 1/8. Now where did we get 8? 8 is the total possible outcomes from tossing a coin. So we only have 8 possible outcomes. That is why the denominator is 8. Next, what is the probability that the number of heads that would appear is 1? Now from our table here on the left side, we have, as you have noticed, we have three outcomes that has one head. So these are tail, head, tail, 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 head, and head, tail, tail. So there is only one head. So that is why the probability that the number of heads that would appear is 1 is 3 out of 8, or 3/8. And it is represented by these outcomes. The next is 2. Then what is the probability that the number of heads that would appear is 2? So from here, from our table on the left side, we have outcomes that have 2 heads, and these are represented by HTH, THH, and HHT. So there are 2 heads, and there are three outcomes that have 2 heads. That is why the probability of getting a head, 2 heads from tossing 3 coins is 3 out of 8, or 3/8. And the last one is, what is the probability of getting 3 heads when you toss a coin 3 times? So we only have one outcome, which is represented by HHH. So that is why we only have 1 out of 8 probability that the number of heads that would appear is 3 heads. So that's why we have here 1/8. Okay, so this is how we illustrate, or how we get the probabilities of the number of heads. And this variable, which is the number of heads, is an example of a discrete random variable. Now, why discrete random variable? Why is the number of heads a discrete random variable? As you have noticed, from our example, we count the number of heads from each outcome. We count how many heads are there in each outcome. That's why this is an example of a discrete, because when you remember how we define discrete, it is countable and it has finite number of possibility or values. And we have here the heads has the number of heads in from our experiment has limited number only. And the important word that you're going to remember is it is countable. Let's proceed. So again, discrete random variable is defined as a variable which can only view a countable amount of values. So you have here the clue, countable. If it is countable, it is discrete random variable. So when we say countable, the values can only be whole numbers. So it has values, it has possible values such as x sub 1, x sub 2, and x sub 3, and so on. So next, this is not found in your modules, but it can help you understand what is the discrete random variable. So we have example, defective cell phones. So suppose two cell phones are tested at random. We want to find out the number of defective cell phones that occur. In order to write the result easily, you use letter D for the defective and N for non-defective. So we only have two cell phones tested at random. As example, there are in Gaisano, when you entered in a Gaisano mall, there are a lot of stores there that sell cell phones. Then you want to test if there is defective or non-defective. Defective or non-defective cell phones. So, for this experiment, we will use letter D for defective and letter N for non-defective. So, we only have two cell phones to test at random. So, we have here the experiment, the occurrence of defective cell phones. And we have here the sample space. So, we only have 4 possible outcomes. So, we have, so sa unang mga pagpili, you get dua ang defective. Dua ang defective or may guba. The other one, the first cell phone is defective. The other one is non-defective or okay siya. The third outcome, so the first cell phone is non-defective or okay, wala guba. And the second cell phone is defective or may guba. And the last outcome is ang duwa, wala guba. So, these are the possible outcomes that you would get when you test two cell phones at random. So, biskan diin lang diri sa apat, ang pwede matabo or pwede matabo kung i-test nimo ang duwa ka cellphone. Now, we have here the problem. Find out the number of defective cell phones that occur. Now, the question is, what is the random variable here? Can you answer this question? What do you think is the random variable here? So it is the number of defective cell phones. So we are concerned with the number of defective cell phones. So this is our random variable. So number of defective cell phones. Now we will try to get the values and the probability of defective cell phones. So we have here the sample space listed on a table. So we have here as what we have done on the first example. We list down our sample space, the outcomes from our sample space. We have 4 possible outcomes. So again, scan din lang di sa ilang pwede matabo sa imo experiment. So we have here on the second column, our random variable, which is the number of defective cell phones. So we are concerned with the defective cell phone. Kambal defective, may guba. Okay, hindi siya okay. So again, we have to count the number of defective cell phones from each outcome first. From our first outcome, how many defective cell phones are there? Of course, we have 2 defective cell phones. That's why we have here the value as 2. On the second outcome, how many defective cell phones do we have? Of course, we have 1. On the third possible outcome, how many defective cell phones are there? So we have 1. And on the last outcome, how many defective cell phones are there? Of course, there is no defective cell phones. That is why the value is 0. What is the next step? Right, we are going to summarize our values. We have here the first column, the number of defective cell phones, so labeled as X. So we have here from our values from the left, from the table found on the left, so we have here the possible values is 0, 1, and 2. So that's why we have here 0, 1, and 2. So we will try to get the probability of X, the probability of our random variable. So what is the probability that the number of defective cell phones is 0? So we only have 1 out of 4, and it is represented by NN. So there is no defective cell phones, that is why the value is 0, and the probability is 1 out of 4 because we only have 1 here, and it is represented by NN. We only have 1 here. 1 out of 4. Why 4? Because we have 4 total outcomes. Next is 1. What is the probability that the number of defective cell phones that would appear is 1? As you have noticed, we have here 2 possible outcomes that has 1 defective cell phone. So 1 defective cell phone represented by DN and ND. So we have here two possible outcomes that has 1 defective cell phone. So that's why the value is 2 out of 4. And the probabilities can be expressed in a simplest form because it is still fraction. So 2/4 or 1/2. The last one is 2. What is the probability that the number of defective cell phones is 2? So the answer is 1 out of 4 because we have here 2 defective cell phones as in our first outcome represented by DT. So we only have 2. We only have 1 outcome that has 2 defective cell phones. So I hope you understand that. And this is an example of a discrete random variable. Why? Why is it that the number of defective cell phones is considered as discrete random variable? Right? Because the values of the number of defective cell phones is countable. And you have noticed we counted the number of defective cell phones from each outcome, and the values are represented by whole numbers. So this is an example of a discrete random variable. Next example, we have distance traveled. So this is an example number 2. Please refer to your modular or to your last. Let me read. Suppose an experiment will be conducted to determine the distance traveled of a certain type of car given 5 liters of gasoline over a prescribed test course. So, this is an experiment. So, meron tayong type of car. So, are you familiar with type of cars? Traveling. So, each car has given 5 liters of gasoline. So, bawat kotse, merong 5 litrong gasolina para subukan kung hanggang saan aabot ang 5 liters of gasoline. So, hanggang saan aabot ang 5 litro ng gasolina. So we have here the table that shows the data for our distance traveled. So on the first column of our table, we have here the types of car. And on the second column, we have here the distance traveled for each type of car for 5 liters of gasoline. So for the Mitsubishi Mirage, we have here 80 and 6500 kilometers. For the Nissan Sentra, we have 58 and 4900 kilometers. For the Toyota, we have 65 and 7900 kilometers. For the Ford, we have 34 and 100 kilometers. And for the BMW, we have 58 and 1400 kilometers. By the way, what is the random variable here? So the random variable here is the distance or the distance traveled by each car. So distance. Now, what can you notice about the values of our random variable? So if you have noticed, the values are, are not expressed as whole numbers. So apart from a whole number, you can notice that there is a part of a whole number which is expressed in decimal, form. What else? So the values are not countable, or these values are uncountable. Instead, of course, by the way, why not countable or uncountable? Countable. Because, of course, distance cannot be counted. Instead, distance is measured. Now, comparing the values from our previous examples, the values, of course, are not expressed as whole numbers. Why? Because the distance cannot be expressed as whole numbers alone. Why? Because there are instances that the distance traveled are between two whole numbers. Example, let's take 80 to 81 kilometers, for example. Between these two numbers, there are also values between these two numbers. Example, you can have 80, 80.1, can have 80.2, 80.3, 80.4, 80.11, 80.12, 80.22, and so on. So it has infinite values. That's why we do not have whole numbers alone here. We cannot express distance as whole numbers alone, because there are values between whole numbers which can be expressed as distance. Now, the question is, what do you think is the type of our random variable? What kind of random variable do we have here? So the distance traveled is an example of a continuous random variable because the set of possible outcomes is not countable. We cannot count the distance, and it does not take values that are whole numbers. So you have here, if we are trying to understand continuous, then we can have a shortcut as it is expressed as in decimal form. It can take values between whole numbers. It does not take values as whole numbers. So this is an example of a continuous random variable. So we have here more examples of a continuous random variable. So example, height of a grade 11 TVL learners. Of course, height is not countable, but you can measure it, and the values does not take um it does not take values that are whole numbers, because height can be 162.25, 162.24, so on and so forth. Same with weight. Weight is not countable. Time is not countable. And time, you can have time as infinite, or it's not countable. It is continuous because you can have time as 1 hour and 25 minutes, and 10 seconds and 2 milliseconds and so on and so forth. So it is continuous. Next is the distance, of course. The distance traveled from Lemery to Iloilo City and vice versa. These are examples of continuous random variables. So a continuous random variable can be defined as a value that is being acquired by measuring. So we have different tools used for measuring. We can have tape measure, weighing scale, so on and so forth. Meter stick, and so on. So thus, a continuous random variable x can take possible values on a continuous scale and can take values between, take note, between x sub 1, x sub 2, x sub 3, and so on. So you can have values between x sub 2 and x sub 3. So on and so forth. So remember this. A random variable is a variable whose value is a numerical outcome. So numerical expressed in numbers. Of a random phenomenon, it is a capacity that connects a real number with every component in the sample space. It is a variable whose qualities are controlled by chance. In this manner, a random variable is a numerical amount that is derived from the results of an arbitrary trial or experiment. And discrete random variables are variables that can take on a finite number of distinct values. Examples are number of heads acquired while flipping a coin 3 times, the number of relatives an individual has, the number of students present in a study hall at a given time, and so forth. For continuous random variables are variables that can take an interminably uncountable number of potential values, regularly measurable amounts. Examples are the height or weight of an individual, the time an individual takes for an individual to wash, time, temperature, item thickness, length, age, and so on. So we have here examples of random variables. So this is, try to take this as an activity to practice your skill, whether you know how to determine the type of a random variable. Example, the experiment, record the number of hours and a specific student used their mobile from 8 a.m. to 5 p.m. for the past 3 nights. So the random variable here is the number of hours a specific student used their mobile phone from 8 a.m. to 5 p.m. So what is the type of variable here? Since our random variable is the number of hours. So this is discrete. Why discrete? Because this is countable. It is only concerned with the number of hours. Number of hours can be expressed as whole numbers. So hours, it is not, we're not concerned with the minutes, seconds, and milliseconds, and so on and so forth. But we are just talking about, we are concerned about the hours. Hours can be 1, 2, 3. Hours are expressed as whole numbers. But if the random variable is the time, of course, it is already continuous because a time can be hours expressed. It is expressed as hours, minutes, seconds, and so on. Next, buying 2 trays of egg in the market. The random variable is the weight of x. What is the type of a random variable here? Correct. We have continuous. Next, recording of the gender of family members in a family with 3 children. Our random variable here is the number of boys among the children. What type of random variable is this? Correct. Discrete. Next, students will prepare for a quiz in mathematics. The random variable here is the time. The time spent reviewing for this quiz. So this is continuous. Again, take note, time is different from hours. So if it is specified, then we can count them as whole numbers. But if it's not, like the time, because time you can have 1 hour and 25 minutes and 30 seconds and 4 milliseconds and so on and so forth. So this is continuous. Next, rolling a pair of a dice. Rolling a pair of dice. Random variable is the numbers appeared in a pair of dice. Numbers. Correct. This is discrete. So I hope you are all got the correct answers. So if you do, I guess you're mastering this skill.